Hi, everyone. My name is Pranoy, and today I'm here to present my thesis on my final project, which is titled as Enhancing Intrusion Detection and Forensic Awareness through Cloud Log Redundancy. So this project basically focuses on strengthening cloud native cybersecurity through uh, platforms like AWS and Azure. As we know, cloud infrastructures today are highly distributed, making centralized log monitoring both challenging and risky. And a single point of failure, such as compromised log account, can result in log tampering, or deletion. And this compromises forensic investigations. So the risk is compounded by detecting delays. The longer the attack goes unnoticed, the greater the chance that critical evidence is lost. So my project basically responds to this challenge by applying principles of by leveraging multi-cloud serverless pipelines to improve log availability and security posture. So it's basically a closed cloud log redundancy mechanism which act as a powerful deterrent against insider threats and advanced persistent attacks. So to look at the abstracts, the proposed frameworks will integrate AWS CloudTrail with Microsoft Azure Blob Storage using serverless AWS Lambda functions, and logs are automatically transferred and hashed using SHA-256 encryption and verifies through .hash.txt files. Any suspicious activity like unauthorized log deletion or use of blacklisted IP are automatically triggered, and real-time alerts are created through Amazon SNS service. And finally, the project also focuses on a pipeline with Microsoft Sentinel and S Defender, which are integrated together, basically structured for log ingestion and automatic security incident creation. So while there are present solutions for secure logging, there are no fully automated closed cloud pipeline which combines integrity verified backups with real-time detection. So our project comes in the situation which existing options are often tied to single cloud vendor, making them pretty unstable for organizations seeking flexibility and independence. There are also practical need for approaches that are lightweight, scalable, and affordable, particularly for small and medium organizations. So this project is designed to direct these gaps, creating a solution which is automated and vendor neutral and cost efficient. So these are the main research objectives of my project, which is the first and foremost, we have to create a serverless pipeline to transfer AWS Cloud logs to Azure in real time. Second, we will implement SHA-256 hashing for integrity verification. Third, to detect any suspicious activity and trigger immediate alerts. Uh, we will implement Microsoft SAS subscriptions, and to integrate logs to Microsoft Sentinel for advanced monitoring. We will implement, we will create rules to detect suspicious activity and activity in AWS account. There were a few incidents in the past which showed the relevance and importance of this project. The first one being the Capital One breach, which happened in 2019, where attacker was able to access and delete all of the AWS logging data, which was crucial in the forensic investigation process. And another one being the Team TNT campaigns, where cloud uh, attackers were able to disable the cloud logging features, and which was very essential for the post incidents in the investigation process as well. So, to talk about the design overview of the project, the system is designed in four key layers. The first one is redundant storage, the log storage, which ensures that the log is generated in AWS and is consistently mirrored in Azure storage. And so the second layer is integrity enforcing layer, which generates the SHA-256 hash files and store them alongside with the logs in uh, the containers. And the third layer is a Lambda function layer, which will pass the logs for suspicious patterns like delete trail or malicious IPs. And the final layer of this project is the Azure Sentinel and Defender layer, in which logs are ingested into Sentinel, where Microsoft Defender detects incidents and create automatically based on the malicious activities. And talking about the implementation part, the first implementation part, the AWS in here, the process begins with the cloud trail, which stores all the activity logs in an S3 container storage. And an S3 event trigger will automatically invoke the first Lambda function. This function downloads all the new log files and generates the SH256 hash for the integrity verification process. And it uploads both log files and hash file to Azure blob storage. And second phase, the second Lambda function focuses on detection. It decompresses the file and passes each logs, which look for high risk incidents. And if there is an incident which matches the specifications, it will immediately send an SNS alert to the person who is administering the account. And last section of AWS is with the IAM roles, which follow least privilege principles, allowing only the specified permission which is needed for the operation. Next is the implementation in Azure, in which blob storage container will receive log and the hash files, and a logic app is then created, which will patch for changes and triggers an Azure function which will process the logs into Sentinel workspace for log analysis. And the Microsoft Defender is pre-configured with the AQL rules to detect specific threat patterns, which will automatically create security incidents when triggered. This is the implementation workflow of our project, and this is a architecture diagram of our project, which comprises of the AWS components and the Azure components as well. Moving on, so talking about the results, one of the key outcome of our project was confirming that cloud redundancy work seamlessly in real time, which AWS cloud logs were transferred immediately to Azure Blob without any delay. And to ensure the logs were not altered or transit, each file was paired with an SH256 hash file. And this in turn allowed for automated integrity verification, uh, proving that the logs remained untampered. And the second part of the result, in which the detection and alerting pipeline proved to be highly responsive, which will help in identifying critical events such as delete trail commands or login from blacklisted IPs. And once it's detected, it will automatically send alert emails to users. And logs were seamlessly streamed to Microsoft Sentinel environment, where pre-configured defender rules help to create automated incidents. So these are the major test cases which we verified during the project, in which we analyzed log transfer was achieved, integrity verification using SH256 was achieved, and we were able to alert suspicious event detection and trigger within 3 seconds. And SIM ingestion through Azure Sentinel was achieved, and we also achieved zero false positives. Although the implementation was functional, there are notable limitations in our project. The first one being the solution requires active integration between AWS and Azure accounts, which can be a barrier in single cloud environments. And this project is not at all tested in large scale or high frequency data, which have to be tested more, which will have to understand under heavy loads. And the third one being the detection approach is static and rule based, which may uh, create issues when an unprecedented event occurs. And there are no continuous hash verification or ML integration attached to the project at the moment. To conclude, this project offers a serverless multi-cloud logging enhanced logging mechanism, which enhances the forensic readiness during an investigation process. It ensures that logs remain untampered and readily available for forensic analysis during an incident. So the architecture achieved low latency detection and alerting, which enables rapid incident response. It also offers real-time alerting and SIM integration, which can be further clubbed with machine learning technologies. Overall, this is a practical foundation for enhancing cloud log resilience and security visibility in hybrid cloud environments. To begin with the demo of this project, I'll start with the AWS Management Console. So here you can see the CloudTrail service, which I have enabled here and created, which is log file validation is enabled. So basically what CloudTrail log does is it monitors and logs all activities which is happening in the AWS Management Console, which includes user sign-ins or API calls or any sort of activities are logged into these logs. And these are logs are actually stored in an S3 bucket, which you can see here. So this S3 bucket uh, save all these CloudTrail logs into a container called CloudTrail. We'll have a look in the S3 bucket, which store all the CloudTrail logs. So if you come to the properties tab in here and come down under event notifications, you can see a trigger is being created here, which basically create a new event whenever there is a new object, which means whenever there is a new log file being created, which is a lambda function. So we will open this lambda function. Lambda function enables sending of logs from S3 uh, bucket to an Azure blob container. So if you come to the code, so this is basically Python code which we use to particular Python libraries, which is Bodo3 and Hashleaf. So Bodo3 is basically an Amazon AWS SDK for S3 bucket communication, and Hashleaf is used for generating SHA-256 hashes. And if you look into the code, so what it does is it extracts the S3 bucket whenever there is a new object being created, and it will create uh, uh, shard SH256 hash for each of the log files which is being created, and it will upload the log file along with the hash file to the Azure blob container with the help of a SAS token, and which means whenever there is a new log being created, it is backed up to the Azure blob container, which make this setup tamper evident. Now we will switch over to the Azure portal. So here you can see this is the Azure blob storage which we have created to store the cloud trail logs which we received from AWS along with the hash files. So if you open this log, this container and go to this particular trail backup container, you can see all the logs which are being created is being backed up in here along with the SHA-256 hash files. As you can see, uh, each log files which is titled as .json.gz has a corresponding .hash.txt file next to it. Uh, if anyone modifies the log, we could recompute the hash locally and compare it with the stored hash values to detect the changes immediately. After AWS console again, and we'll open our second Lambda function, which basically is a log parser and notifications system. So as you can see, this is a Python code, and we have configured particular suspicious events, which are delete trail or stop logging or create user. So if this Lambda function detects any of these events from the cloud trail logs, it will automatically trigger an SNS service which we have created. So this is the SNS service which we have created. So if the Lambda function triggers any of those services, it triggers this SNS service. And we have made a subscription as well. So it will send an alert to this particular email, which means whenever there is a critical incident happening in our AWS environment, we will get instantly to our emails. Now we will test this in our setup. So I have already prepared a cloud trade log which contains a simulated delete trail event, and I'll now upload it to the S3 bucket which we have configured cloud trade logs. So once we upload the particular log file, we'll go to the live CloudWatch cloud logs. So here, if you see, we can see there is a new alert created for a suspicious event, which we have created earlier. So if you click on it, it says alert sent for one suspicious event, which means our Lambda function are triggered, and we should get an email uh, regarding the incident in our inbox. So if you see here, we get a new alert which has all the information regarding the attack, which the affected bucket, the particular event which triggered the incident, and the originated IP. So we'll get all this information in our inbox. We will look into the SAM setup, which I have set up in Azure platform. So as you can see, this is the logic app which I have created. If you go to the logic app designer, you can see the different components which I have set up here, which included triggers to retrieve the log content and pass the JSON file and to post the log files into the Azure Sentinel platform. So as you can see here, this retrieves log content and here the JSON file is passed, which means it sends a records to the Azure function, which it then posts to the Azure Sentinel through HTTP function. Now, I'll go to the Microsoft Sentinel and run a query on the log which is created in Sentinel. So, as you can see here, uh, we can see the log entries which come from AWS platform, which have the details such as event source, event name, and all the informations. Within the Sentinel platform, I have also enabled different analytics rules. For example, here are two analytical rules. One which detects the AWS root login without multi-factor authentication, and another which detects any attempt at deleting the cloud trails. And I'll also show you the incident tab, which automatically creates custom incidents and alerts with respect to the analytical rules which we have created. So as you can see here, the rule has triggered in the past and automatically generating an incident for the SOC team to investigate further.